Okay, the last curve that we want to calculate the length of is a cardioid, this one. The name of cardioid, well, this is the description of this curve in polar coordinates, right? And the shape of this curve is given by this picture, the cardioid here. Okay, and that's why it's called a cardioid, because it looks like a heart. It'll be like a heart. Okay, so we have the parameterization, right? So if we want to remember, x is equal to r cosine theta, y is equal to r sine theta, the same theta that we have here parameterizing. So x is equal to 1 plus cosine theta times cosine theta, which is cosine theta plus the square of cosine theta. And this one is 1 plus cosine theta times sine theta, which is sine theta plus cosine theta sine theta. All right. Okay. So we have the parameterization. Now we have to take the derivative of the parameterization. Okay, as a function of theta. And that is here is cosine theta. The derivative is minus sine theta plus. Oh, sorry, minus the derivative of, well, plus the derivative of this, which is minus 2 cosine theta sine theta. Okay, and then this one, remember that this is just 1/2 of the sine of 2 theta, which would be easy to take the derivative of this, right? So the derivative of this is the cosine theta plus 2 times 1/2 the cosine of 2 theta, so cosine of 2 theta here, right? This here is the sine of 2 theta. So what we have found is that this is equal to minus the sine of theta minus the sine of 2 theta cosine of theta plus the cosine of 2 theta. Okay, right. Now we take the length of this. We're going to take the length square. So it's the square of this. So sine theta plus sine 2 theta square, and cosine theta plus cosine 2 theta square. So we square this and we get sine square plus sine square 2 theta plus 2 times sine theta sine 2 theta plus cosine squared theta plus cosine squared 2 theta plus 2 times cosine theta cosine squared 2 theta, cosine 2 theta. Okay. Now you have the sine squared plus the cosine squared, that is 1. Sine squared plus cosine squared is 1 again, so 2, right? And then we have 2 sine theta sine 2 theta plus cosine theta cosine 2 theta. And this, remember, is just the cosine of 2 theta minus theta, okay? Which is the cosine of theta. So what we get here is just 2 times 1 plus cosine of theta. Okay, right? Now we take well, this is this is the length squared, right? And we can put this in a better way, relating it to half the angle, because this expression here is 2 times the cosine squared of theta half. So this is 4 times cosine squared of theta half, which is much better to calculate the square root of, because then the length, the square root of this is just 2 times cosine theta half, of course, absolute value. Okay, now we have to integrate that. That's the length, right? We have to integrate that. between 0 and 2 pi, because the parameterization is from 0 to 2 pi, okay? So it's the integral of, well, 2, this constant 2, the integral from 0 to 2 pi of the absolute value of cosine theta half, right? D theta. And we just make a change of variable, a very simple change of variable, which is theta half equal to phi, which means d theta is to d phi, right? And so this is 4 times the integral from, for theta 0, phi 0, for theta 2 pi, phi is pi, and then we have the absolute value of the cosine of phi, d phi. Okay, the cosine between 0 and pi half, well, between 0 and pi half is the same as between pi and pi half, but with the opposite sign. But since it is the absolute value what we have here, we could multiply by 2 and integrate only half the interval, but now we get rid of the absolute value. And the primitive of this is the sine, so we have 8 times the sine of phi between 0 and pi half. Sine of 0 is 0, sine of pi half is 1, so this length is just 8.